Okay, so that's your first job. You count how many carbons, so that's hex. Then you look on this side. We're going to start numbering closest to this side because that's the double bond. 1, 2, 3. So it comes after the first carbon, so it's hex 1E.
So we got a functional group.
The functional group is the double bond, yeah, between two carbons. So it's the group of atoms that forms the center of chemical activity of the atom.
What do they mean, the center of chemical what?
That is what causes it to react. So the double bond would be more reactive than a single bond. So, and if you have, you'll learn next year, you're also going to get hydroxide. So then there will be an OH that makes it an alcohol. So it's what makes it belong to a specific group of molecules in organic chemistry. So the double bond tells us that it's an alkene, which is going to be more reactive than an alkane. So that's why they say it's a center of chemical activity of the molecule. Okay, so hex 1N. So now, if I ask you to give me a positional isomer, what are you going to do? Okay, so when I say position, there must still be hex, but the number must change. So it's going to be, a positional isomer would be something like hex 2E. Yes. Can you now see it's a definition? There goes the light. Oh, I love that. Okay, the functional group is changing position. So this functional group moves from being after the first carbon to after the second carbon.
But a chain. Oh, sorry.
So when it's a positional isomer, it just changes position.
Yes, the functional group changes position.
When it's a chain isomer, then, for example, one of the carbons would go and create a side chain.
Yes, so then it must still be 1N.
Yeah.
So the 1N is going to stay there, but you're going to still, yellow is quite a good color. 1, 2, 3, 4, for instance, or even 5. That is still going to be there. So it's still going to be 1N.
It'll be 3-methylpentene if you put it on the third one.
So if you put it there, yes, it would
And that'll
be
be a chain isomer.
3-methyl.
Okay.
So
What is
would
it?
be found a
Bent.
isomer?
Because the chain length is different. So here you had a hex, here you had a pent. So the chain doesn't have the same length anymore.
So when it's
This,
chain isomer, it has a different length.
yes. That's what does the definition say for chain isomer? Anza? You also got the definitions.
Something with the same molecular formula but different. You said chain.
Different chain length. That's the definition. So it's the same molecular formula, different chain length. Okay, it could be a combination of the two, but just make sure that if they say positional isomer, the number must change. If they say chain isomer, the base name must have a different number of carbons.
Positional is functional chain.
Functional group moves. So it's that number must be different.
So then structural would be what?
Okay, so if it's a structural isomer, all of them are structural isomers. So a chain isomer is a structural isomer and a positional isomer. They're all structural. Under structural, there are two different ones. Okay,
So just
but
structure then, okay.
yeah, so all of those were structural isomers of that.
That is the difference. Like
But
structure
some are
isomer.
chain isomers and some are positional isomers.
So there's only those three. Right?
Mm.
Oh, okay.
Yes.
And I forgot what you said. The chain isomer is just different
Length.
length.
Okay, but now what they can ask you for this, okay, let's just make this a little bit better. Let's say that was the molecule. Now give me a name for this, please, Carl.
So it'll be 5-methylhexene.
Something wrong? 5-methyl,
Hex 1.
5-methyl hex 1N.
Do you need a dash between methyl and hex?
Please no.
And then the 5 in the middle.
I got 5 now.
Let me just try again. 5 dash methyl, then
X.
hex 1 in dash 1 in. No gaps.
When do you put the A in?
Only when it's a diene.
When it's a die?
When there are 2 double bonds.
Oh, so when it's a hex
Hex.
1 die, or hex 1, 2 die.
Exactly. Okay, but now moving on. So for this one, please give me the name very quickly without even thinking of a positional isomer of that thing.
5-methyl hex 2E.
5 methyl hex 2-ene or 4 methyl hex 2-ene. Okay, you can change that as well. Okay, the other thing, you can also say, and if I ask you for a positional, a chain isomer,
5
methyl pent. Pent 1 E.
okay, so you can't have, you must still have the same number of carbons. So if you say 5 methyl, so you're going to have 2 methyls. So you're going to have to say 5, 4 dimethyl pent 1-ene. So can you see the numbers stay the same? So it's not a positional isomer, but the chain length, here it was hex, now it's pent. So the chain length is different. So it's a chain isomer. Do you see the difference between them now? Okay. You're fine. We did that again. Do you see it now? You looked as if you were drifting there for a second. Okay, it's my superpower. Okay, so
What's the I don't understand the difference then.
yeah, see, I thought you would, yeah. Okay, so when it was hex, so the chain is 6 long. Now it's pent, so the main chain is 5 carbons long. So the longest chain here was 6 carbons. The longest chain here is 5 carbons. So that is why we can call it a chain isomer, because the length of the chain is different.
Now I'm going to go in like 5 minutes. So can you quickly do a bit of energy?
That's all you needed for organic, eh?
No, I needed the condensed structure now.
Okay, so let's just do the condensed structure for this thing. So that is structural. If you have all the H's, all the C's. Condensed structural, we don't have many rules. So you go with your carbons, you write down your carbons, and you go, okay, I've got, in this one, I have 6 carbons. So you're going to go 1, 2, 3, 4, 5, 6. After each carbon, you write what hangs on that carbon. So on this carbon, what is it touching it?
3
H3. On this carbon, what is touching it?
And it's a 3 of it. Oh, no. 1. Oh, 1.
A hydrogen. But there's also a whole methyl hanging on it.
So what did you write there?
So you put the methyl in brackets, CH3. Okay, I'm going to do it again. Okay, so you write the first carbon with its 3 hydrogens. Then you write the second carbon and you look what hangs on it. A hydrogen and a methyl.
So what about the other? Oh, that's a.
Yeah, we're getting there. Do them one at a time. So hydrogen and a methyl. But if you just go CH3, it's going to look as if it's part of the main chain. And that is why we put it in brackets, because this thing that's in bracket is hanging still onto that carbon.
Okay.
Okay, then we go to our next carbon. So we've done this one, done that one. Now we're at this carbon. What's attached to that carbon?
2 H's.
2 H's. Then we're at this carbon. What's attached to that?
2 H's.
Oh, sorry. Also 2 H's. Then we're at this carbon. What's attached to that? Only 1 H. What's attached to that carbon? Oh, I actually made a mistake. Remember, there can only be 4.
That's it.
That's it.
So the fact that there's only one H with that one means, is that what tells you about the double bond?
Yes, if you see, there's only 3 here, then you know it's a double bond.
Oh.
Okay. 'Cause
That's
otherwise,
condensed structural.
how would you indicate the double bond?
In a you can if you want to. There's very few rules, so you can actually even go and put that in there if you want.
Okay.
Then one more question, man. When there's two things, man, two side chain, like two carbons on the side chain, man, what do you call
Then
it?
you can do that.
Okay, and then what do you call it, man, like when you write it, when you're naming it?
Dimethyl.
Dimethyl. Oh, okay, and then when there's another one somewhere else.
Still
like different-
dimethyl.
Still dimethyl.
Yeah. It will just be it can't be one, like 3,5 dash dimethyl.
So when would you put in ethyl?
Oh, that is if there's 2 carbons on the same side chain.
That would be an ethyl.
This will be an ethyl now. So this will be 2-ethyl. But be careful, 2-ethyl could make your chain longer, which it is doing here. So this becomes your longest chain then. So 2-ethyl doesn't really exist. 1-methyl and 2-ethyl can never exist because it will make your chain longer.
One methyl.
Because you can't put a methyl here because it actually makes your chain longer.
One methyl and two ethyl.
Can never exist because it makes your chain longer.
But wouldn't two methyl make the two chains the same length?
Yeah, 2-methyl is fine.
But then, which one would you make your main chain?
Doesn't matter. You choose.
'Cause I
The
guess
one that you don't
so-
choose becomes the methyl.
Because the formula was.
Thank you so much, man.
Okay. All right, energy. So for energy, you need to know what is on this one here. Potential energy of the chemicals. Okay. So potential energy of the chemicals, here it's the course of reaction. Not time, because some of them happens very fast, some of them happens very slow. Okay. Now, you start here with a certain amount of energy. What does that energy represent?
The chemical energy stored in the reactor.
Yes, in the reactant. So it's a point. It's not a gap, it's a point on your graph. So if this one here says 300, it means the reactants.
So would that be energy in or energy product or
It's-
energy reactant?
It's energy reactants. It's not energy in.
Okay.
We haven't put any energy in yet.
Or energy in is the.
Gap.
Thank you, ma'am.
Okay, so this is the reactant's energy. Now, to get them to react, what must I do? I must break those bonds apart and form. That's the minimum energy that I require to break them apart. What do we call that energy? Activation energy, yes. So I'm going to put in a bit of energy. So that energy that you put in is the energy needed to break the bonds of the reactants. So that's my energy in, or also called my activation energy. So now these reactants don't exist anymore. They have changed to a substance that's there, that we call what? Activated complex. So that energy again is a point. So let's say that's 700 there. So the 700 is for the activated complex. The 300 is for the reactant. So what's the energy in? 400. It's a gap. It's not a point. So here, this is going to be 400, and you get that by saying 700 minus 300.
I thought the activation energy.
It is the activation energy. Energy in and activation energy is the same thing. Then, this is now always going to now give off energy so that they can form new bonds. So it's going to give off energy, and I'm going to end up somewhere over here with products. I could end up there with products. So if I end up there, I'm losing energy. Energy is given out.
Would that be an endothermic Because it lost less energy than it put in.
Yes.
If it
So
goes in
this is the energy that's out. But if I ask you if this value here is 450. Now I ask you for the energy of the products. What are you going to say? 450. Because that is a point again. It's the energy of the products. So here, the energy of the products, you're just going to say 450. Don't do a minus sum. It's just 450. But if I ask you for energy out, what are you going to do? That's going to be the 700 minus 450, and that is going to be your 250. And now we can ask you from that, what is delta H? And then you're going to say that is energy in minus energy out. So energy in is the 400 minus the 250, and that gives me 150 kilojoules per mole normally, but you use whatever the unit is here. And because the answer is positive, I know that the chemicals has now more energy. Where did they get that energy from? Environment. That is why the definition for endothermic is heat energy is transformed into chemical potential energy. Okay, so there's a lot of these graph things that you need to interpret in your paper. Basically all it is. And then if I don't end up there, but I end up all the way down here, and I give you the here, that is 100. Tell me, what is the energy of the products now, Anza? It's just 100, because it's a point again. It's not an interval. You can grab it. It's in that cupboard at the back. So, and then if I ask you for E out now, how are you going to get it? 700 minus the 100. So E out now is going to, no. Energy in and energy out are always going to be positive values. So it's going to be 700 minus 100 is still 600. But now if you go and work out delta H, it's going to be energy in again minus energy out. And now this becomes 400 minus 600, which gives us minus 200. So now the chemicals has less energy. So where did that energy go? Environment. Exothermic.
The other formula is products minus.
Yeah, so that's what I was just going to say. The other formula, you can say here, it's energy of my products minus the energy of my reactants. So let's see if we get the same answer. The energy of my products there was 50. The energy of my reactants was, what do I get? Can you see? Please no.
I have to get it on.
And if for this one, it would be the same. So the other formula here would also be energy products minus energy reactants. Let's see, energy of these products is 100 minus the energy of the reactants, that was 300. Can you see it also gives you minus 200, which is the same as that answer. And that one is the same. So it doesn't matter which formula you use, you'll get the same answer. You must just not get confused with a point. So if you say energy products minus energy reactants, it is the point here minus the point there. But if you say E in, E out, it's that gap there and that gap there. Okay. Thanks, you too. Are you okay with this, Anza?
Yes,